So there's one more group of compounds that we're going to learn how to name, and these are acids. And we can recognize acids because they always start with hydrogen. At least in this class they do. So we look at a formula like HCl. The first element being hydrogen says, ding, that's an acid. So we can think of an acid as being a molecule that has one or more hydrogen ions attached to an anion. Acids are not technically ionic compounds, but many of them, when you put them in an aqueous solution, they do ionize and form ions. And so we often think of them as containing ions. So acids are going to be hydrogen and something else. So there's two kinds of acids. Of course, there can't just be one kind, right? There's two kinds of acids. The first kind does not contain oxygen. So if we look at these examples, they all start with H, and there's no O anywhere, no oxygen. So these guys are named according to this pattern. We have the prefix hydro, and then we find the element, or there's this one instance where we have an ion, and then we change the ending of that to -ic, and we add the word acid. So we look at HCl, starts with an H. This is chlorine. So we put the prefix hydro on it, hydrochlorine, but we change the ending to -ic acid. So hydrochloric acid. This is a weird one. CN, if you look that up in the table, that is cyanide. And yeah, that's the same thing that spies use to kill themselves. Cyanide. Well, you change the ending of that to -ic acid, you get cyanic acid. Put the prefix hydro. Hydrocyanic acid. So the hydro part is standing in for the H, and the chloric is standing in for the Cl. This guy down here, H2S, hydrosulfuric acid. Now why does this one have a 2? And this one's got a 1, and this one's got a 1. Well, this is where it's helpful to think of acids as ionic, even though technically they aren't. What's the charge on a chloride ion? It's in group 7 in the periodic table, right? So we start at group 8, we count backwards, it's got a -1 charge. Hydrogen as a cation has a +1 charge. So how many of each of them do you need to get it to add up to 0? You just need one of each, right? So HCl. Let's look at hydrocyanic acid. Well, cyanide is Cn minus. Cn -1, H +1. We just need one of each. What about sulfur? What kind of an ion does sulfur form? Forms a 2- ion, right? Because here we have sulfur. Argon is 0, chlorine's -1, sulfur's -2. Well, the hydrogen ion is still +1. So we need 2 of those to balance the charge on the sulfide. So that's why it's H2S. That makes sense? So here's a table of those acids. Sometimes they're called binary acids, which works really well except for hydrocyanic acid. This is acids that do not contain hydrogen, do not contain oxygen. And that's almost like a Monty Python name or something. Acids that do not contain oxygen. So there's hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid. That one's a little hard to say. But if you think of the prefix hydro, and then this is iodic, hydroiodic acid, hydrocyanic acid, hydrosulfuric acid. They all start with that prefix hydro. They all end with the word acid. And the ending here is -ic. Not ite or ide or ate or anything like that, but ic. And when we look at their formulas, none of them have oxygen. And really, those are the only ones we're going to encounter. Just those guys right there. But there are also acids that do contain oxygen. And these have a better descriptive name. These are called oxyacids. Just like the oxyanions were anions with oxygen, these are acids with oxygen, oxyacids. So if the anion contains oxygen, then we take the root name of that anion and we mess with it. So if the root name ends in ate, we change the ending to ic. So let's look at these examples. Here we've got HNO3. Okay, the H makes it an acid. NO3 is nitrate. We looked it up in the table. I have the table in my head. So 8. We get rid of 8 and we replace it with ic. And so this becomes nitric acid. There's no hydro. It's not hydronitric acid. It's just nitric acid. How about this guy? H2SO4. Well, the hydrogen tells us it's an acid. We look at the rest of it and we see, oh, there's oxygen. So then we need to identify the name of this oxyanion, the polyatomic anion, sulfate. We take off the 8 and we put on ic acid. Sulfuric acid. Now this one adds the UR back, and that happens a lot with sulfur. The UR kind of comes and goes. I guess sulfic acid sounds dumb. I don't know. It's always sulfuric acid. So that's one of those little anomalies. Sorry about that. But sulfate, that's H2SO4, that's sulfuric acid. Okay, and this last one, there's a lot of letters in there, right? But it starts with an H. So look at what's left. The H is by itself. That makes it an acid. We're looking at what's left. There's 3 elements there. Well, it's definitely a polyatomic anion. Go look it up in the table. Its name is acetate. So we take the 8 off. And this is acetic acid. That's acetic acid. It's all about patterns. So, chemists got together and they looked at all these different kinds of compounds and they said, okay, let's put these in groups that have common characteristics. And what's the most efficient way to name these things? And so we name everything that starts with an H as an acid, and we name things that have metals in them as ions. Any questions? We got something more to go here. What if the name of the anion ends in ite? Ite, there we go. Well, then we change the ending to us. So now we've got eight goes to ic, and ite goes to us. How do we remember that? Well, I've got a silly sentence for that one. Rick ate him before he could bite us. Is that silly? Okay, so ic and ate go together. it and us go together. It's remembering these two pairs and how did they line up. Rick ate him before he could bite us, or you can think of, you ate something that didn't taste very good and you said ick. So ick and ate go together, and then the other two must go together. However you want to remember it. So let's look at these guys. HNO2. Starts with an H, it's an acid, it's got oxygen in it. So then we're going to cut off the H and look at the name of the rest of it. We look that up on the chart, and it is nitrite. Nitrate was O3. Nitrite is the light version, it's got O2. So we switch out ite for us, and this becomes nitrous acid. Nitric acid is HNO3. Nitrous acid is HNO2. H2SO3. We see the oxygen, and so we're going to cut off the hydrogens and see what the name of the rest of it is as an anion. Well, that's the light version of sulfate. That's sulfite. Ite and us goes together. And again with the sulfur, the UR comes back. So this is sulfurous acid. I'm giving you multiple choice exams, and I will not trick you by putting sulfurous acid and sulfus acid as both choices on an exam. So try to remember the UR coming back, but if you don't remember, it'll be okay. We got to get these endings right, though. HClO2, we see the H, we say this is an acid, and then we look for oxygen. It's got oxygen in it. So we're going to cut off the hydrogen and look at what's left. We name that, and then we tweak its name to make an acid name. ClO3 is chlorate. This is chlorite. We change the ite to us, and we get chlorous acid. Any questions? So we've got two kinds of acids. Ones without oxygen, we use the prefix hydro, and those all end in ic acid. And then we've got the ones with oxygen. Rick ate him before he could bite us. If the oxyanion has an ite ending, we change the ending to us. If it's got an ate ending, we change it to ic. I think we've probably got an example here. Well, here's a table of some common oxygen-containing acids. Nitric. So here's nitric acid, nitrous acid. The difference is one oxygen. Sulfuric and sulfurous. Here's phosphoric and acetic. These are all common acids. I think we've got just a flow chart, no more examples. So when you recognize that it is an acid because it starts with H, you ask, does the anion contain oxygen? If no, then you use the prefix hydro, and you take the root name of the anion, whether it's chlorine or bromine or whatever it is, you change the ending to ic. And so you get hydro something ic acid. If it does have oxygen, then you look at the name of the anion. If it's ite, you change it to us. If it's ate, you change it to ic. Well, there's an example. This is fun because it mixes a bunch of different things together. And according to my iPad, we've got 1 minute. So, which of the following compounds is named incorrectly? Well, this could take a while, huh? Anybody see one that just kind of jumps out at them? Well, let's look at them here. KNO3. K is potassium. That's an ionic compound. And NO3 is nitrate. Potassium doesn't need a Roman numeral, so potassium nitrate, that's good. TiO2. Ti is titanium. Titanium is a metal over there. Needs a Roman numeral. It's got a Roman numeral. But is it the right Roman numeral? Well, let's check that. We've got 1 titanium and we've got 2 oxygens. What's the charge on oxygen as an ion? 2 minus. And it says we've got 2 of those, right? So that's a total of -4. And this name is telling us that this is 2 plus. Is that going to work? No. So that's the one that's wrong. That one's wrong. It doesn't say there's only one. Tin 4 hydroxide. Well, SN is tin. Does tin need a Roman numeral? Yeah, tin's over here in group 4, but that's not 1, 2, 3 zinc or silver. It needs a Roman numeral. Then we have to check and make sure that the Roman numeral is correct. Hydroxide is the correct name for that ion. It's -1. 4 of those would balance a 4 plus charge, and that's what we've got. So that one's okay. This one's 2 nonmetals. We can use prefixes. Phosphorus. Penta means 5. Bromide, so that one's good. How about this last one? HSO3. It's one of those oxyanions. Ignore the hydrogens. What's the name of that? Well, you look it up in the table, sulfite. So then, is this the correct name for that acid? It is. So only B was incorrect.